Chapter 1 Science and Planet Earth. Words to know: astronomy, coordinate system, density, earth science, ecology, geology, inference, meteorology, observation, oceanography, percent deviation, science, scientific exponential notation. This chapter will help you answer the following questions. What do we mean by earth science? Why is earth science important? How do scientists make, use, analyze, and communicate their observations and measurements? Science has played a central role in the advancement of civilization. The Latin origin of the word science can be translated as to know. While some people might think of scientific conclusions as unchanging facts, our understanding of nature is never complete. As the understanding of nature grows, old ideas that no longer fit our observations are discarded. The so-called facts of science are often temporary, whereas the methods of science, observation, and analysis are permanent. Therefore, science is a way of making and using observations. See Figure 1-1. Figure 1-1. Students and professional geoscientists investigate Earth through fieldwork and laboratory analysis. These students are learning about rock that millions of years ago intruded into older rock. Field observations reveal that intruding material was a molten liquid that has since cooled and solidified. Science often attempts to answer such questions as, why do we see the moon on some nights but not on others? What causes clouds to form? Why are there violent storms, earthquakes, and volcanoes? How can people wisely use Earth's resources and still preserve the most valued qualities of our natural environment? What is the history of Earth and the universe? If we could see our planet from far away in space, we might be more aware of what a tiny part of the universe we occupy. Rational thought and clear logic support the best scientific ideas. Scientists often use numbers and mathematics, data, to present their results because mathematics is considered to be straightforward, logical, and consistent. These qualities are valued in scientific work. Visit the following website to see From the Sky. Scientific discoveries need to be verifiable. This means that other scientists who investigate the same issues and make their own observations should arrive at the same conclusions. For example, when a climate prediction is supported by the work of many scientists and or by computer models, the prediction is considered to be more reliable. Science at work. Alfred Wagner proposed his theory of continental drift in the early 1900s. It was based on indirect evidence. During his lifetime, he could not find enough evidence to convince most of the other Earth scientists that continents move over Earth's surface. However, new evidence gathered by other scientists working 50 years later gave renewed support to his ideas. Today, plate tectonics, as the theory is now known, is supported by precise measurements. This is a good example of how the efforts of many scientists and new observations resulted in a new way of thinking about how our planet works. Science can therefore be defined as a universal and ongoing method of gathering, organizing, analyzing, testing, and using information about our world. Science provides a structure to investigate questions and to discover relationships and patterns and form conclusions. The reasoning behind the conclusions should be clear. Scientists will continue to evaluate and modify conclusions. The body of knowledge of science, even as presented in this book, is simply the best current understanding of how science works. Student Activity 1-1. Good science and bad science. Sometimes it is easier to understand science if you look for what is not science. Tabloids are newspapers that emphasize entertainment. They publish questionable stories that other media do not report. Bring your teacher a science article from a questionable news source. Your teacher will display the stories for the class to discuss. What are the qualities of these stories that make them a poor source of scientific information? What is earth science? The science you study in school is often divided into 4 branches: life science, biology, physics, chemistry, and earth science. See Figure 1-2. Earth science applies the tools of the other sciences to study our planet, including its rocky portion, its ocean, its atmosphere, its interior, and its surrounding in space. Earth science can be divided into several branches. Geology is the study of the rocky portion of Earth, its interior and surface processes. Geologists investigate the processes that shape the land, and they study Earth materials such as minerals and rocks. They also actively search for natural resources, including valuable minerals, ores, and fossil fuels. Meteorology is the study of the atmosphere and how it changes. Meteorologists predict weather and help us to deal with weather-related disasters and other atmospheric events that affect our lives. They also investigate climatic, long-term weather changes. Oceanography is the study of the oceans that cover most of the Earth's surface. Oceanographers investigate ocean currents, how the ocean affects weather and coastlines, the composition and properties of seawater, and the best ways to manage marine resources. Astronomy is the study of Earth's motion and motions of objects beyond Earth, such as planets and stars. Astronomers consider such questions as: is the Earth the only planet of its kind? How big is the universe? When did the universe begin? And how will it end? Many Earth scientists are involved in ecology, or environmental science, which seeks to understand how living things interact with their natural setting. They observe how the natural environment changes, how these changes are likely to affect living things, and how people can preserve the most important characteristics of the natural environment. How is earth science related to other sciences? Earth science draws from a broad range of other sciences. This helps present a broad view of the planet and its place in the universe. Earth scientists need to understand the principles of chemistry to investigate the composition of rocks and how they form. Changes in the weather are caused by the energy exchanges. By knowing the chemical properties of matter, scientists can investigate the composition of stars. The movement of stars and planets obey the laws of physics regarding gravity and motion. Physics helps us understand how the universe formed and how stars produce such great amounts of energy. Density currents and circulation of fluids control the atmosphere, the oceans, and even changes deep within our planet. Nuclear physics has allowed scientists to measure the age of the Earth with remarkable accuracy. The earth sciences also make use of the principles of biology and in turn support the life sciences. Organic evolution helps us understand the history of the Earth. At the same time, fossils found in the rock are the primary evidence for evolutionary biology. The relationships between physical, non-living, planet, and life forms are the basis for environmental biology. Only recently have some people understood how changes in Earth and changes in life forms have influenced each other throughout long periods of geological time. Figure 1-2. The four major earth sciences draw on the fields of physics, chemistry, and biology to investigate Earth systems. Why study earth science? Although some students may become professional earth scientists, it is more likely that you will find work in another area. No matter what career you choose, earth science will affect your life. Everyone needs to know how to prepare for changes in weather, climate, seasons, and earth movements. We also need to become educated citizens who make important decisions in a democratic world. Natural disasters are rare events, but when they occur, they can cause great loss of life and property. To limit loss, people can prepare for earthquakes, tornadoes, floods, volcanic eruptions, earthquakes, and climate shifts. Humans can survive the effects of cold and drought if they plan ahead. However, people need to know how likely these events are and how best to avoid their devastating consequences. We need to know the answers to many questions such as: how will humans be affected by general changes in climate? Can these changes be prevented? Will a large asteroid or comet strike Earth? And how will it affect Earth's inhabitants? Our civilization depends on the wise use of natural resources. Fresh water, metals, and fossil fuels are among the great variety of materials that have been supporting. Our civilization depends on the wise use of natural resources. Fresh water, metal, and fossil fuels are among the great variety of materials that have supported a growing world economy. These resources have brought us wealth and comfort. We need to know how much of these materials are available for use, what will happen if these materials run out, and what is the environmental effect of extracting, refining, and using these resources. These issues affect all of us, regardless of our profession. As citizens and consumers, we make decisions, and as citizens, we elect governments that need to consider these issues. Environmental awareness. As you will read in future chapters, the natural environments of this planet have changed dramatically over the past 4.6 billion years. They continue to change, and we must expect change in the future. Humans do not control the environment. We are a part of the environmental chain. With or without human influences, change will occur. However, we can certainly affect how those changes occur. For example, there has been a campaign to use paper cups rather than polystyrene foam cups. Most people think of paper as a less harmful material. However, some studies have found that the environmental effect of paper cups can be greater than that of polystyrene foam cups. Sometimes the full story is not as simple as we're led to believe. For more information, visit this website. On the other hand, it's clear that human-caused emissions of carbon dioxide are having a global effect on the environment. But unlike the choice between paper or foam cups, the solution here is very difficult. People enjoy the convenience of using cars and the comfort of indoor heating and cooling. Alternative energy choices such as nuclear or renewable energy can be unpopular or too expensive. What can we do when people prefer to use cheaper or less controversial alternatives now rather than following long-term economic and scientific choices? Complex or potentially costly issues such as these are the most challenging problems. There's an environmental saying, think globally and act locally. This is a good idea. It stresses personal responsibility for environmental choices. We currently see that rapidly developing economies throughout the world are placing new demands on Earth's limited resources and creating more waste. More than ever, nations must learn to work cooperatively to solve global environmental problems. Working with science. Cynthia Chanley, water rights lawyer. Cynthia Chanley is not an earth scientist, but she knows how important it is to understand the earth. She earned a degree in geology. After several years of working in the mining industry, she attended law school and became an environmental lawyer. Ms. Chanley now works as a water rights lawyer. She says, I constantly use my geoscience background to influence the use and preservation of an essential resource. However, these issues go well beyond my profession. Everyone needs to understand our planet's interconnected system to determine how resources can be most effectively managed for ourselves and for future generations.